Hello everyone, welcome to Learn with Wasim. This is Muhammad Wasim Khan, an instructor of your project planning and management course. I hope you all are doing well. As you know that in the previous few lectures we have discussed the project schedule management and its processes and the project cost management and its processes. Today we are going to discuss project quality management. Before starting the lesson number 8A, the project quality management, let's discuss the disclaimer. That is, in preparation of this lesson, materials have been taken from different online sources in the shape of books, websites, research papers, and presentations, etc. However, the author does not have any intention to take any benefit of these in his or her own name. This lecture is prepared and delivered only for educational purposes and is not intended to infringe upon the copyrighted material. Sources have been acknowledged where applicable. The views expressed are presenters alone and do not necessarily represent actual authors or the institution. After successful completion of this particular lesson, we will be able to comprehend the project quality management knowledge area and the associated processes. We will understand the processes of quality assurance with its associated tools and techniques, and we will understand the process of perform quality control with its associated tools and techniques. So the lesson plan is that first we will discuss what actually the project quality management is. So we need to introduce the quality management and we will introduce it in the first part of the lecture. Then we have the plan quality management, its tools and techniques and processes. Then we have the perform quality assurance and perform quality control. So today we are going to discuss the project quality management and plan quality management. Project quality management include the processes and activities that determine the quality policies, objectives, and responsibilities. So the project quality management is one of the knowledge areas of the project management, and it includes all those activities and processes that establish the quality policies and the objectives of the quality and quality responsibilities. So the project quality management works to ensure that the project requirements, including the product requirements, are met and validated. So in this particular knowledge area, we need to ensure that the project requirements and the product requirements or service requirements, etc., they are all met and validated. So therefore, we have the three basic processes, that is the plan quality management, perform quality assurance, and perform control quality. So let's discuss the plain quality management. It is actually the process of identifying the quality requirements or standards for the project and its deliverables. So in plan quality management, we need to identify the quality requirements of the project or different activities of the project or the standards of the project and its different activities and deliverables. So we need to identify the quality requirements for the project, and that is actually the plan quality management. Here we actually document how the project will demonstrate compliance with the relevant quality requirements. So we actually document here in the plan quality management that how the project will, conform with the relevant quality requirements. So let's discuss some inputs, tools, and techniques and outputs in the plain quality management process. The inputs include the project a management plan, stakeholder register, risk register, requirements documentation, enterprise environmental factors, and organizational process assets. So we have discussed all of these six inputs in the previous lectures again and again. That's why we are not going to discuss it here. We will discuss the tools and techniques that include the cost benefit analysis, cost of quality, seven basic quality tools, benchmarking, design of experiments, statistical sampling, additional quality planning tools, and meetings. So we can't use all of these tools and techniques. It's not necessary to use all of these tools and techniques that are you can see on the screen, but we need to identify the tools and techniques from this particular list, or some other tools and techniques that we can use in a particular project. Then we will have the outputs, and the output include the quality management plan, obviously, the process improvement plan, quality matrix, quality checklist, and project documents updates. So let's discuss the tools and techniques. So these are the quality plan quality management tools and technique. The first one is the cost benefit analysis. And the main primary benefit of meeting the quality requirements, including less rework, high productivity, lower costs, increased stakeholder satisfaction, and increased profitability. So for any project, we need to fulfill the basic quality requirements, and those requirements are less rework. We don't want to work again and again and again on a particular part or activity of a project. So that's why we need the less rework. We need the higher productivity. We need the lower cost. We need to complete our project with a lower cost and increase the stakeholder satisfaction and increase the profitability as well. So for that, we need to perform the cost benefit analysis. And in cost benefit analysis, we actually compare the cost of the quality and the expected benefit from those particular quality measures. So if the benefits from the quality measures are more as compared to the cost of the quality, then that would be obviously the preferable process. The second one is the cost of quality. So cost of quality includes all costs that are incurred by investment in preventing the non-conformance to requirements, appraising the product or a service for conformance to requirements, and if failing to meet the requirements, that is rework. So cost of the quality include all of the costs like investment in preventing the conformance to requirements, so non-conformance requirements, sorry. So if you want to prevent the non-conformance of the standards to the requirements, then you need to invest in preventing those particular non-conformances. Okay, and if you want to appraise or evaluate the product, or assess the product or service for conformance to the requirement, if you want to identify whether the standards are conforming to the requirements or not. So when you invest in that particular process, that is called appraising cost. And the last one is the failure cost, meaning if you fail to meet the quality requirement, if you fail to meet the quality requirement of the project, excuse me, or the product or services that you are going to produce, then that is called the failing cost, and you need to rework again in order to meet the requirements and to produce the error-free products and services. So failure costs are often categorized into the internal cost or external cost. And failure costs are actually those costs that are found by the project team members. Okay, so if the called the internal failover cost, and the second one is external failover cost, and these are actually the found by the customers. For example, when you produce a product, okay, or you manufacture a product, and your project team members identify the errors in that particular product, then that is called internal failover cost. Okay, so another one is the external failover cost. Mean, for example, when you produce a product and you deliver it to the customers, and when the customer identify the errors or the problems in that particular um, product, then that is called external failover cost. So let me ask you that which cost is very dangerous, the internal or external? Yeah, the external one, because it is, it will affect the reputation of a particular company if the customers found any particular problem in, a particular product. Okay, so failure costs are also called the cost of poor quality. Then we have another tool, and we call it the seven basic tools of quality. So we can have different quality tools, like the seven basic tools of quality or the new seven tools of quality. These are the tools that we actually discuss in the total quality management course. But here I would like to just give you a brief introduction of each and every of the seven basic tools. So we will discuss here the seven basic tools of quality. The first one is these basic tools of qualities are actually presented by or established by the Ishikawa, Dr. Koro Ishikawa, who was a Japanese quality guru. So the first one is the cause and effect diagram. The second one is the flow chart, and the third one is the check sheet that you can see on your screens. So let's discuss the cause and effect diagram. We call it the fishbone diagram. We call it the Ishikawa diagram as well. Why we call it the fishbone diagram? Because you can see here that it is like the skeleton of a fish. This particular box represent the head of the fish, and this represent the vertebra, or the vertebra of, or the vertebral column of the fish, and these are actually the ribs. These are actually the ribs that of the fish, and these small subdivisions of the ribs actually represent um, the branches of ribs. Okay, so a cause and effect diagram is actually a diagram that is used to identify the basics and the root causes of a particular problem. So what we do here, we actually write a problem in this particular box, or in the head of the fish. We write the problem, and then we draw a straight line from the head of the fish, and that line is divided into different major causes, or major branches, and these major branches represent the major causes. For example, here in this particular figure, you can see that one of the basic cause is the method, another one is the environment, another one is the people, and the fourth one is materials. So here we will actually discuss or identify all of the causes regarding the materials. Here we will discuss all of the causes regarding the people. Here we will show all of the causes of this particular problem regarding the environment, and here we will just show and discuss all of the important method related causes that cause this particular problem. Okay, so in the cause and effect diagram, we actually draw a fishbone diagram, and in the head of the fish, we actually write the main problem. Okay, and in the main branches, we actually write the major causes of this particular problem. And those major causes are further divided into the sub or minor causes of this particular problem. So by this way, we can identify, the root causes of a particular problem. Okay, so when we eradicate those root causes, we can eradicate, this particular problem. So this is called cause and effect diagram. The second one is the flow chart. So flow chart is actually a chart that represents a process, from start to end. And in this particular flow chart, we represent each and every important and major, part of the process. Okay, so for example, here we have started the process. Okay, this is started. The project start here, and the first we will have, perform this. We'll have to perform this step, and second we will have to perform this step, and third we have to perform this step, and then we will have the feedback system as well. So we can use, different boxes for different purposes. For example, you can see here that this particular parallelogram is used for decision. Okay, so here you can see that parallelogram is represent the decisions in this particular flow chart, and the rectangles represent the different steps, and these arrows represent the direction that which steps to be performed first and which steps to be performed second, and so on. And this particular symbol represents the starts and end of the flow chart. Okay, the third one is the check sheet. So check sheets are actually used to gather data regarding different problems or regarding different processes. For example, if you want to identify, the strokes and the frequency. Okay, for example, this is the one of the um, cause of the problem. Okay, so we can say, for example, let's talk about the brain stroke. Okay, and here one of the cause is the stress. So we can here say that, okay, um, stress, we will actually mark a tick here. Okay, that represents that, yes, stress is one of the causes of the brain stroke. Okay, and then we will here use the frequency. For example, uh, if your stress level is um, 5, then you will get a stroke. Okay, so we actually use the frequency here. Okay, that is the familiarity of actually, or the frequency of um, occurrence of the stroke. Okay, so these are actually the check sheets that actually identify and gather the data. So cause and effect diagrams, or fishbone diagrams, or Ishikawa diagrams. Um, the problem statement placed at the head of the fishbone is used as a starting point to trace the problem's source back to its actionable cause. And I have discussed this particular diagram in the previous slide. Then the flow chart is also called the process step. It displays the sequence of the steps and the branching possibilities that exist for a process. Then it shows the activities and the decision points and the branching loops and the parallel paths and the overall order of the process. And the third one is the check sheets, or we call it the tally sheets. And it is used to organize the facts in a manner that will facilitate the effective collection of the useful data about a potential quality problem. Then we have the Pareto diagram and the histogram. So Pareto diagram is actually, we call it a 20 by, it is actually a diagram that is based on the 20 by 80 rule. It is actually a specific form of the vertical bar chart and are used to identify the vital few sources that are responsible for causing most of the problem's effects. So this is the Pareto diagram. It is based on the 20 by 80 That means that 80% of the problems are due to the 20% of the causes. Okay, so Pareto diagram actually represent the um, problems, the amount of problems that occurs due to a particular amount of the causes. Okay, so for example, you can see here then this much problems. This much causes produce this much problems. This much you can say causes will produce this much problem. This much causes will produce this much problems, and at the end, this much problem will produce this much problem. So you can see here that these small causes, these 20% of the causes have produced, 80% of the problems. So Pareto diagram actually is used to identify those few those few causes that actually are responsible for the 80% or most of the problems. Okay, the second one is the histogram. So it's actually a special form of the bar chart and are used to describe the central tendency, the dispersion, and the shape of the statistical distribution. So here you can see this is actually the histogram. It is actually a bar chart, and it actually represented the frequency or the distribution of the data that we have actually gathered in, for example, check sheets. So if we have identified and gathered the data in the check sheets, then we need to plot it here. And when we plot it in the form of the histogram, so histogram actually gives us the particular, the shape of the statistical distribution of that particular data. And this is, you can see, the center is actually the mean or the average of that particular data. So when your data is near to the center here, at the center of this particular graph, that means that your project or process quality is good. But when it moves, to any of the extreme, either on the right or on the left side of this particular graph, that means that your product quality is decreasing. Okay, or you can say is um, or you can say that the product quality is I would say not going to be very good at the extremes. So this is the histogram that actually represent the quality using the statistical distribution. Then we have the control charts in the scatter diagram. So control charts are actually used to determine whether or not a process is stable or has predictable performance. Upper and lower specification limits are based on the requirements of the agreement. So you can see here that control charts actually have the upper control limit, UCL mean upper control limit, and lower control limit. Okay, and we have the average. So these are actually the data. You can see these points or these peaks of this particular line are actually the data or the output of each and every process. Okay, so if the outputs of this process is near to this average line, that means that your process is of very good quality. And when the output value moving away from this average line, for example this point, if we consider this point, then that means that our quality is reducing and the process is getting uh, you know is moving towards out of the control. But if the data, for example, you can see here, if the output points or the data crosses the upper or lower control limit, that means that the process is not within our control, and we need to move it into uh, an area where we can control the process. Okay, so simply we can say that if the data or the output is within these control limits, upper and lower control limits, then that means that the process is within our control. But data exceed any of the upper or lower control limits, then we can say that the process is not lower control, and we need to take the um, what we can say, we need to take steps or measures to improve our process and bring it into the control limit. Then we have the scatter diagram. So scatter diagram is actually a diagram that plot ordered pairs and seek to explain a change in the dependent variable, for example, the y in relationship to the change in corresponding to the independent variable. So scatter diagram is actually used to identify the relationship between the dependent and independent variable. For example, here you can see the dependent variable is cost and the independent variable is time. So that means that with changing the time, the cost will also change. Okay, so with changing one variable, the other variable will change. With changing the schedule of the project, obviously you will have to change the cost. Okay, for example, if you want to reduce the time, you need to increase the cost of a project or activity of a project. Okay, so scatter diagram is used to show the relationship between two different variables, and these dots are actually the data, and we have plotted the data in the scatter diagram. Then other tools and techniques include the benchmarking. So benchmarking involves comparing actual or planned project practices to those of comparable projects to identify the best practices, generate ideas for improvement, and provide a basis for measuring performance. So benchmarking is actually a process in which we compare our processes or our projects or our products with a date of the standard products or processes or project. That is called benchmarking. And benchmarking helps us to improve our practices, improve our process, to generate the ideas for improvement, and to provide a basis for measuring performance. I would like to give you an example. For example, if your university wants to improve the quality of the management department, then your university will try to compare their management department and its processes with the management department and processes of a high quality university. Okay, so for example, if we consider the Pakistani universities, so if the Comsets University want to improve the quality of the management department and its processes, then the Comsets University will compare its management department and its processes with that of the management department of Lum's University. Okay, in order, so when Comstate University compare its processes with the Lum's University, then in that case the Comstate University will improve its practices, will create the new ideas for improvement, and it will provide a basis for measuring performance. So benchmarking is actually used to compare a project or organization or a process with the standard one in order to improve it. Okay, then we have the design of experiment. So design of experiment is actually a statistical method for which is used for identification of all those factors that influence the specific variables of a product and or service. Okay, and then we have the statistical sampling. So sometimes it is very difficult to investigate each and every part or each and every step of a process. So in that cases we actually consider some samples. We take some samples from the population. For example, in engineering project, for example, we have the 75 drawings. We have a list of 75 engineering drawings. Okay, then it is very difficult for us to investigate each and every of the 75 drawings. So what we need to do, we need to select just 10 engineering drawings out of the 75 drawings. Okay, so that is called the statistical sampling. Then we have the meeting. So I'm not going to discuss the meeting, as you know that we have discussed it again and again in the previous lectures. And we have some additional quality planning tools as well, like brainstorming. We have discussed brainstorming, that it is actually a technique. It is used to generate the ideas. The force field analysis. Force field analysis are actually the diagrams, um, diagrams of the forces for and against the changes. That force field analysis are actually the diagrams that identify the forces that are required for the change or that are required against the change. We have the nominal group techniques as well. Again, this technique is discussed in the previous lectures. That this technique is actually used to allow the ideas to be brainstormed in small groups and then reviewed by a larger group. And at the end, we have the quality management and control tools, and these tools are used to link and sequence the activities that are actually identified. Then let's move toward the outputs of the plan quality management. The first one is the quality management plan. So obviously, quality management plan is, it is a subsidiary plan. It is one of the component of the project management plan. Okay, and we have discussed that in the first and second and third chapters. So it is actually a component of the project management plan, and it actually describes that how the organization's quality policies will be implemented. So this plan actually tells the organization that how the organization will implement its quality policies on the human resource, on the product, on the processes, or on the project. So it also describes how the project management team plans to meet the quality requirements that are set for the project. Then we have the process improvement plan. If you identify a problem, then what will you do? You need to, when you identify a problem, you need to identify the cause, the root cause, using any of the seven basic tools or the seven new tools. And when you identify the root cause, you will have to eradicate it and improve it. Okay, so for that we need to have the process improvement plan, and it is actually a subsidiary or component of the project management plan. And all details regarding the steps for analyzing the processes to identify activities that enhance their value are actually a part of this particular plan. And we have the quality matrix. So a quality matrix specifically describes a project or a product attribute and how the control quality process will measure it. So quality matrix are actually these are actually the metrics that identify or describe the project attributes and the product attributes and how the control quality process will measure it. For example, if you want to manufacture a product, okay, a mechanical product, then what would be its quality matrix? Its size, its shape, its weight, and its finishing, etc. So these are actually the quality matrix. So if you want to produce a good quality, a high quality mechanical product or part, you need to take care of all these quality metrics. Okay, so the tolerance defines the allowable variations to the matrix. So for every matrix, we usually have the tolerances. For example, if you want to, uh, you know, um, let me tell you about the weight of a product. For example, uh, if you want to produce a product, mechanical product, or manufacture the mechanical product, then you can say that okay, its size can be plus 10% or minus 10%. For example, the basic size of the mechanical part should be 5 kilograms. Then you can say, okay, we can, it is It doesn't matter if the size of the part is 5.1 kilogram or 4.9 kilogram. And that is called a tolerance that is allowable. uh, Quality checklist. So a checklist is actually a structured tool, and it is used to verify a set of the required steps that has been performed. And many organizations have standardized checklists that are available to ensure consistency in frequently performed tasks. So quality checklist is actually a list which actually tells us, or which actually realize that whether we have to perform all the quality, or we have to measure all the quality attributes or not. Okay. For example, if you, again, if you want to manufacture a mechanical product, then the quality checklist for that mechanical product would be, for example, the size of the product is 5 plus minus 10% 5 plus minus 10 kilogram. Okay, then you will have to check it or uncheck it. If you have yes, if you have performed that quality measure, then you will check it, or you will tick mark it that yes, we have considered this particular quality uh, measure. And if you didn't took that quality measure, then you will have to uncheck it and go back and perform those quality measures uh, and complete it. Okay, then we have the project documents updates. Project documents that may be updated include but are not limited to the stakeholder register or the responsibility assignment matrix and the verbal down structure and verbal down structure dictionary. So as you know that we have discussed many times in the previous lectures, that when you perform any changes in any part of the project, then you need to go and update the relevant project documents. Okay, so that is another out of the plant quality management. Okay, so where are we now? What is the project quality management? We have discussed it. What is the quality management plan? Again, we have discussed it, and we have discussed its processes, its inputs, tools, and techniques, and outputs, and we have discussed the seven basic rules as well. So, inshallah, we will move toward the second part of this lecture in the coming lectures. So, if you have any question in this particular part, you can, ask me. And again, if you didn't, if you do not have any total quality management course in your program, then you can go to the Learn with Wasim YouTube channel or Facebook page, and you can, you can watch the videos regarding the seven basic tools and new seven tools of quality, like the Ishikawa diagrams and control charts and affinity diagrams, etc. Okay, so that's it for today, and inshallah we will. I'll see you. I'll see you in the next class. Till then, thank you.